In this lecture, I'll explain how to build a bucket model of EPS, along with things to be careful of during the process. This photo shows a test model in a Japanese language school in Vietnam. I made it when I was asked to provide a workshop there on EPS and its bucket model making process. This test model is used to purify very turbid, stagnated pond water. I heard that the school is planning to make another bucket model to purify water from the school well for drinking water. Some young Vietnamese teachers are already familiar with the making procedure, so I sincerely hope that the use of EPS will be widely adopted in the community. This is the photo from hands-on learning session on EPS in Iriomote Island. The session was held as part of JICA Okinawa's training program. I think it was about 4 years ago or so. When you construct your own EPS bucket model, first thing you need to think about is the site location and foundation material so that the model will be stable. In the past training, we used this plastic beer stacking crate for foundation, as they are sturdier than other similar plastic products. However, when you plan to build a model in your backyard, for example, concrete blocks or bricks will be good options for foundation. Make sure to adjust foundation height in consideration of surrounding environment of the model site. If the foundation is too high, for example, the model may fall by strong wind during typhoon season, so please think carefully. To imagine how the bucket model will look like after completion, place the parts of the model, such as foundation material and buckets, on its potential location. In this step, consider the direction of drained water flow and roughly determine location and direction of the model, so as well as where to make holes on the buckets. Which side to make holes and which side should the bucket face? These are all important points to consider. Adjusting the height of each tank, in this case bucket, is important. Receiving tank is placed highest. Raw water flows into the receiving tank and heavy suspended matter settles here. Here, you need to consider the kind of raw water you will be using. It is because receiving tank needs to be big if your raw water is river water with a possibility that turbidity level may go up time to time. If you will be using rainwater, small receiving tank is fine. Let's place model components on their potential location while considering distance and angle between each bucket. When you cut PVC pipes, don't rush. Imagine how the completed bucket model looks like. Think about how long the pipes should be, then cut. We then determine the pipe location and height for URF tank. Regarding the PVC pipe diameter, if you are making a small bucket model for your own use, PVC pipes of small diameter is fine. But depending on the bucket size, and total model size, you may need to choose pipes of larger diameter. When you determine where to cut the pipes with a pipe cutter or a saw. For the outlet of water from the receiving tank, again, think carefully where to make a hole. Mark it with a pen, then open a hole with a drill. Apply the drill bit perpendicularly. Make sure you don't force the drill bit through, because the bucket may crack. Such cracks will become a cause of water leak, so be careful. This photo shows how we make a drain hole for URF tank. Gravels needs to be washed with water first. Utilizing rainwater is a good idea. Before you place the gravels in the tank, put them in the bucket filled with water first to make sure the water doesn't get cloudy. Wash the gravels again if necessary. If the gravels are from clean river, they probably don't need a lot of washing. Now, gravels are filled in the URF bucket. Again, before you make holes, determine the location and mark it with a pen, then open holes carefully. Hole height and location are very important. This is a hole located on the lower side. Since it is a bucket for EPS tank, you will be making two holes, one for draining and the other for filtered water outlet. Again, hole location is crucial. Make them near the bottom, but not too much, so that PVC parts can fit into the holes all right. Be careful. The sand I used contained very fine or even powdered sand, so I washed it many times with running water from water hose, and also removed sand that was too small with a net. For a better result, it may be a good idea to double the net to wash sand. Now, preliminary assembling is done. Run water for test run and check if there is any water leak. The sand used that time contained a lot of small powdered sand. I washed it many times, but still water got cloudy. If you can supply raw water freely without recirculating in your EPS plant, this cloudiness in water will be gone after running water for a while and discharging it from the drain. This model has two URF tanks and one EPS tank. Let me show you how water flows in the model. Water flow from receiving tank is adjusted by a valve. The water flows into the thick pipe from the top of the URF tank so that the water is delivered right to the bottom of the tank, then flows through the gravels from the bottom to the top. The water flow pattern repeats in the second URF. Then lastly, the water flows into the sand layer of the EPS tank from the top. At that time, test run was done by drawing water with a small pump from rainwater weir. This plastic bottle is attached to reduce impact from water flow on sand surface. Water falls gently in the tank like a shower. Such use of a perforated plastic bottle is a simple way to make gentle water flow. We confirmed that there was no water leak. Now, our 45-liter EPS bucket model is completed. This is the EPS model used in a workshop on EPS held in Fiji. Those attended the seminar included staff members from Fijian Water Utility, civil engineers, and JICA senior volunteers. Some had already involved in introducing EPS installations in various villages in Fiji, but others were not so familiar with the workings of EPS. So I explained in detail on the EPS system and made a bucket model together with them. Rectangular buckets tend to crack more easily than round ones, so we need to be extra careful with them. Provide support to the bucket edge and apply drill bits slowly and gently, for example. The kind of available pipes are different from country to country. Choose the ones easily available for your EPS bucket model. The transparent rectangular container on the top is a model for raw water receiving tank. The reason why it is very small is because I made it for explanation. When you actually make it, adjust size or shape depending on raw water quality or other necessities. The valve attached to the pipe sticking out from the container is the flow control valve. This receiving tank needs a hole for overflow. This is your F tank. See how internal piping is done. Then purified water flows out from this outlet. At that time, the drain valve cap parts were not available. So as a temporary fix, we improvised by attaching a long pipe to a drain outlet to prevent water from flowing out from there. As you can see, the water level in the pipe will be higher than that of the tank, so the water won't flow out. Everyone was listening to the explanation carefully. This photo was taken on the day of the EPS seminar. Unfortunately, we were unable to use water during the workshop, so water level was indicated on the model with blue-colored tape. We also didn't put gravels to show internal structure. This shows the inside of the EPS tank. Fine plastic net wraps around the perforated, meaning with many small holes, pipe. Next, this is a EPS installed at the residential house in Okinawa. It is a 45-liter bucket model that consists of one URF tank and one EPS tank. It utilizes harvested rainwater for raw water, and the water circulates in the system with a submersible pump. The minimum capacity for a bucket to use in this model is 45 liters. I would say this is the minimum size for EPS because if you use a smaller bucket, water treatment capacity through biological activities may not be sufficient. So make sure to use a bucket with 45-liter or more capacity for EPS tank. Let me show you various types of PVC pipes used for installation parts. I've tried various pipe assembling patterns, and I think this one is one of the effective designs I came up with. Of course, you can freely adapt piping design by yourself, so I encourage you to think of various patterns. This is the internal piping of URF. This trident shape ensures that water flow reaches every corner of the bucket bottom. With a drill, I made holes of about 5 millimeters in diameter. Again, before you drill holes, carefully determine hole locations and mark them with a pen. Make sure to deburr, meaning remove small fragments from the whole surface with a box cutter or something and make it smooth. Or you can simply sand it down with a sandpaper. These are joint parts used at both external and internal side of the joint, mounted on a bucket hole. Rubber seal is placed between joint parts and the bucket wall so that water won't leak. I heard that in Fiji, when such rubber seals are not available, they improvised by using rubber sheet for cars or bicycles instead. This is the internal piping of URF tank. The pipe mounted on the left is the drain outlet. I changed my mind and changed the piping design once again. This time, I made the shape of an inverted trident. Next, I'll make a EPS tank. Holes have to be made carefully. After internal parts of EPS tank are made, assemble them. This time, small holes of 1 millimeter in diameter were made with a drill. You can also make slits with a saw instead. These are the parts that treated water passes through. The upper pipe is for venting air. Treated water passes through the pipe, placed a bit higher from the center. The height of the treated water outlet pipe, I mean the T-shaped part of the pipe, has to be 20 to 30 centimeters higher than the sand surface. We also need a hole for draining on the EPS tank. Again, determine the hole location carefully. Foundation is ready. Now, let's assemble the system. This is the URF tank. Place gravels inside. Choose relatively large gravels to place at the bottom. Next, place middle-sized gravels. Then, place mixed-sized, meaning a combination of small and medium-sized gravels. Notice the shape of the gravels is not important. You can use both round-shaped gravels and crushed stone. The important thing is to place large gravels at the bottom and at the top. In between these large gravel layers, you can mix different sizes of gravels, large and small. This is EPS tank. The internal piping structure looks like this. I made a drain hole after I took this photo. The hole you see on the upper left side is an overflow outlet, and the pipe from there leads to raw water receiving tank. The reason why we need the overflow outlet is because we don't want incoming water to the EPS tank to spill out from the edge and waste it when the inflow is too much. The water that flows into the receiving tank through the overflow outlet is recirculated in the system. Wrap the internal pipes with a fine plastic net, then cover the pipes with gravels. We then place sand. This time, I used river sand from a store. Make sure to wash the sand before placing it in the tank. Place the rest of the sand and gravels after you mount the tanks on the foundation because it is very heavy. The red tank is for harvesting rainwater. The tank receives rainwater and circulated treated water from the EPS tank. Then a submersible pump sends the water to the URF tank. The rainwater tank capacity was increased by adding another tank. The cap placed on the treated water outlet is taken off only when the user wants to get treated water. Other than that, the cap remains so that treated water flows through the pipe back to the receiving tank for recirculation. This is the side view. By the user's request, the system was installed on a sloped area. It's been functioning very well since its installation 3 years ago. This is the water treated by the EPS system I constructed in my backyard. It's safe and tasty. I compare its taste with tap water regularly, and I can definitely say EPS water tastes much better. The sand used in my EPS tank is beach sand. I also use EPS to manage water quality to keep small animals such as Japanese rice fish, guppy, mosquito fish, river snail, freshwater shrimp, and tadpole. There are animals living in this pond too. Except for the fish I introduced in the beginning, they came from outside and made their habitat. Dragonflies visit here often, so we can find dragonfly nymphs in the pond as well. I wash the store-bought sand naturally with rainwater by wrapping it in a net and placing it outside in a large planter. Using this, I am planning to make another bucket model soon. Gravels for URF tanks can be large-sized store-bought gravels of about 50 millimeters in diameter, crushed stone, or stones from friends. Again, make sure to wash it with rain by leaving it in a basket. I also wash it again with tap water to finish. These gravels are also for URF, and they are rather small. I'm washing them in a net so they don't spill off from the gap. I'm taking treated water now. I harvest rainwater from a rain gutter and collect them in multiple plastic buckets. This windshield has been useful for rainwater harvesting. I have 7 45-liter buckets, one 70-liter bucket, one 90-liter bucket, and one 120-liter bucket to store rainwater. I use this small submersible pump to circulate water. I use rainwater for the EPS system, so the raw water supply is not constant, unlike rivers with constant flow. That is why I need to circulate water in the system. The water hose attached to the pump is connected to PVC pipe and a valve. The valve is used to adjust water flow. Since I use EPS water only for drinking and cooking, I adjusted the flow to a small volume and circulate the water. I visually check every day to see if submersible pump is clogged or if flow adjustment is necessary or not, just in case. But for the past 5 years since I installed this system, I haven't washed sand even once, and filter clogging have never happened either. I only removed excessive algae time to time. I also fixed the system with ropes in times of big typhoons, but it has never broken down. Water flow of filtered water is rather slow because I've limited the water flow from the submersible pump in the first place, and because biological activity is slowing down as it is getting colder these days. I'm thinking of opening a valve just a bit to increase water flow. I use multiple submersible pumps. This pump is connected to a long water hose to move around the water to a faraway bucket or to circulate water among many buckets so that water doesn't stagnate. I placed a brick with a hole under the submersible pump so that the pump doesn't clog easily. Now I operate the system to treat about 300 liters per day, but I have also tried with 700 liters per day, and it worked fine with stable flow. The water level in the URF gravels have to be below the gravel surface. It is because if the water level is above the gravel surface, frogs come and lay eggs. Large gravels are placed around the pipes to prevent small gravels from clogging the pipe. Likewise, in this second URF tank, gravels are filled up above the water level, and large-sized gravels surround pipes. As long as raw water is secured, we can get safe and tasty water with EPS. Having EPS system is also useful for securing emergency water supply in times of natural disaster. I'll continue to promote EPS by informing people of its various advantages. This is the fresh, safe, and tasty drinking water from EPS. Cheers!